Hello everyone. So today our project is loan approval prediction. Ever wondered how machine learning can predict whether a bank will approve your loan or not? In this video, we will build a real world project where we predict loan approval using Python, Skitland. And don't worry, I will walk you through each line of code. So let's first see how our model is working. So this is the front page where we will give some value, and after that our model will predict whether your loan will get approved or not. So just in we have to input some value here. Annual income 40,000, loan amount 4 lakh, loan term 24, CIBIL score 500, residential value. Maybe you have to input anything you can, and commercial asset value, and luxury asset value, and bank asset value. So let's predict whether that loan will get approved. So loan approval prediction result is rejected. Why? Reason of rejection also is here. Low civil score, insufficient annual income, high loan amount compared to income, low asset value. So, like this, our model will predict whether your loan will get approved or rejected. How this model is working. So we will see each line of code line by line, and we will understand how this model is working. So let's jump on the code. So you have to open your VS Code, and first I will explain this how I train that model. So let's come here from starting. Yeah. So what about this? So this is our important library. First thing, we imported some libraries. These are the core Python library we will use for pandas for data manipulation, NumPy for numerical operation, matplot and Cbone help us to visualize the data beautifully. After that, I loaded the data here. We and just typing df will print out the data frame. This give us a look at the column value we will working with. Okay, this df, and df dot head to show the data. Okay, so this is our data: loan id, number of dependent, education, self-employed, annual income, loan term, civil score. These data is given by, for example, this data is given by bank, and you have to train our model whether the loan will get approved or rejected. Okay, so this is our data. Okay, after that, df.info. So here we can check the information about data frame. Okay, like every column, what is the data type of each columns. Okay, so number of dependent is integer, or loan id is in integer. I guess you know very well about this, and you came here to learn about how you can make a project. Okay, to check missing value, we use is null.sum. Okay, so there is no missing value in our data. df.column to check column. Okay, it will list all the column name in our data set to great understanding the structure. So if you will see here, then you can see there is gap. Okay, there is a small error is here, so we have to fill this also. Okay, it's not like a error, but if you will not fix this, okay, then might be you will face a problem, okay, unnecessary problem while training your model. So for this I did a string strip. Okay, to fix this blank space here. Now you can see there is no blank space. Now we will come to check the df.save. Okay, save to check how many rows and how many columns are in our data set. Df dot describe will describe the statistical structure of our data. Okay, like mean, max, standard deviation for every numerical value. Let's come again. It's head again information. I'm going to check. Now from here you have to understand what is it. Okay, so from here, first of all, one thing I want to tell you that we can see in our data that education column. Okay, in education column, age data is in a categorical form. Okay, in categorical form. It is in the data. If you will check data type of education, then it is object type. Okay, so machine is always understand numerical value. Okay, so we have to convert this categorical value in numerical value. Okay, so how we will convert this? So we will use encoding technique. Like there is so many, there is various encoding technique like one hot encoder, level encoder. So we are using here. So first I check that this data type. Okay, then I normalize here to make each already. If you will see here, each the words are in lower form, but still I use this, okay, to show you how you can make how you can normalize that column name. And if you will come here, then I use level encoding to for example, if that user is graduated, then we assign 1 here, and if user is not graduated, then we assign 0. Okay, and if you will check again here, then you can see here education, in education column, that all data is in numerical form. Okay, so for example, come here in first data that graduate. Okay, and you will come, if you will check here, this is 1. Okay, so if that user is graduated, then it will assign 1, and if user is not graduated, then we use 0. Okay, so this is level encoding I did here. Same thing I did for self-employed. If you will come to see in self-employed, there is no yes, no yes. Okay, so same I did here. I just make I use normalize. I did normalizing again, level encoding, and after that level encoding, you can see here that self-employed is 0101. Okay, so now again we have to check which same thing you have to do with loan status. So if you will check loan status column here, so in loan status there is written approved, rejected, approved, rejected, rejected, approved. So what we have to do here? So we have to convert this categorical value also in numerical value. Okay, so same thing we will do as like we did here in loan amount and in loan amount and number of independent and education. We did we change already change categorical value in numerical value. Similarly we will do with loan status. Here again I did for approve I use 1, and for rejected I use 0. And if you will come here again to see, then all category value are changed in numerical value. Again I checked df dot information about our data set, then all data is in integer type. Okay, so what I did here, so if you will see here, there is loan ID. Okay, so we have to remove unnecessary thing from our data set, so we can train model in good way. Okay, if we will not remove, then might be our model will not get trained well. Okay, so if you will check here loan ID, so we don't need loan ID here. Okay, 1 2 3 4 5, we don't need this loan ID. So what I did here, I just remove, I just drop loan ID. Okay, so if you will see again df dot head, then there is no loan ID. Okay, and I created a count plot here to see that loan status by education level, how many graduated get loan approved and rejected, and how many not graduated get loan approved or not get approved. Okay, so this is a pivot table. Okay, for average civil score for both graduated and not graduated. And again if you will come here to see that heat map, why we are creating heat map? So the main thing to create heat map, to check the correlation between each column. Okay, like if we will check here bank asset value, and the relation between bank asset value and number of dependent is in positive. Okay, and if you will check here, we can see that if you can make a correlation between each column. Okay, like loan amount, if you will check loan amount with number of dependent, then you can see it is in positive. So same thing, we make a heat map to check correlation between each column. Okay, so this is the main reason to creating heat map. Okay, so again what I did, I just make box plot to check outlier. So we can see here that for each column there is box plot like number of dependent, box plot for education, box plot for self-employed, for income annual. And if you will focus on this graph, then you can see in commercial asset value and residential asset value and bank asset value, there is some outlier. So we have to make normalize. Okay, we have to we have to standardize it. Okay, so we have to make normalize. So how we will fix this outlier? So for to fix this outlier, I use Q1 Q3 quartile method. Okay, so using this method, okay, I just fix I just fixed that outlier. Again, I make a box plot. Then if you will check that box plot for residential asset value, commercial asset value, and bank asset value, then you can see that outlier has gone because it is normalized. Okay, so again I check df.info, df.head. Okay, now the main thing is coming here, from where we will train our model. Okay, so how we are going to train our model? So we are splitting. Okay, we are segregating dependent and independent variable here. Okay, for example, we separate our feature with the x from a target y. Okay, so our target is y. Okay, and our data is there. This is dependent independent. Okay, and we will split, and we are dividing data into here. Yes, here we are dividing our data into 80 for training and 20 for testing. Okay, so our test set you can see here, it is 20. Okay, and we will come here, then we can see our data set. Okay, that 11 columns are there, and 3415 data is for training and 854 data is for testing. Okay, so again we did scaling the feature. Okay, and we fix the scaler on the training data to transform both training and test set. Okay, and I use logistic regression. Okay, one of my favorite algorithm in machine learning, logistic regression. Okay, and it is very good to do classification. Okay, if binary for binary classification, logistic regression is good. Okay, so you can use random forest classifier. There is many algorithm for classification, like decision tree, random forest. Okay, so I did evaluated the model. Okay, and that accuracy I got 91. Okay, and there is confusion matrix about this model. Okay, so I hope you already know this confusion matrix, what is it. Okay, yeah, so this is our classification report. Okay, what accuracy we got, 91. Okay, you can do hyperparameter tuning also, and I use grid search CV. Okay, after this also I got the best parameter is C1 penalty L1 solver libnizer. Okay, so that best score was 91. Okay, and if you will check the accuracy also, that accuracy is same. You can do fine tuning also. Okay, so just for that, till now we got accuracy is 91. Okay, and this is you can find individually accuracy, precision, recall, f1 score. Okay, and after training the model we got accuracy of 91%. Now we will do what we will do, we will make pickle file. Okay, so we will make a pickle file. Here we can see that loanpay.pickle. Okay, and you have to always save this pickle file in write byte mode. Okay, and again I did one more for scalar pickle. Okay, and again I saved in write byte mode. When you will run this code, that pickle file will come here. Okay, it will save in your local storage, and now we have pickle file. Okay, so we trained our model, now we have pickle file. What we have to do now, we have to make a framework now. Okay, so how we will make a framework here? So we will make we will use flasks to integrate. Okay, we will connect front end with back end. Okay, like when the user will input like for example, if we will see here, this is front page. Okay, and this model is back end. How these both are going to get connected? So these both are going to connected with using flask. Okay, so we will explain this flask. Now we will see that flask code. Just give me a 1 minute. uh, Sorry for taking your time. Okay, so now we have a pickle file. Okay, now we will build a prediction web app. Okay, using flask and machine learning. Okay, so already we did machine learning and we trained model. Okay, now why we are creating this? So user can input their loan detail. Okay, and app will predict that loan will get approved or not. Okay, so let's get start from here. So these are the important library. Okay, this is the core library. Okay, so Flask for microwave framework we are using. Request for that request. Okay, this request help us to grab the data from the website. Render template allow us to connect a html file, and we also imported pickle to load our machine learning model and pandas and numpy for data manipulation. Okay, so this line is initialize the Flask app. You can think of this as the starting point of your web server. Okay, so now we loaded two important library. Sorry, we imported two important thing here. The scalar, this is scalar. Okay, the scalar to normalize the user input just like we did during training. Okay, while training also we did scaling. Okay, and here also we have to use that scalar pickle file. Okay, so we have to always you have to use read byte mode. Okay, and my pickle file is in model. Okay, so you have to give your local storage, not local storage location. You have to paste your pickle file location. Okay, where that your pickle file is stored in your system. Okay, so my pickle file is in model scalar. Okay, and this what about this model, model logistic regression dot pickle. Okay, so in this case a logistic regression we use dot pickle file. Okay, and what about this form this function. Okay, so this function is super cool. It helps us to explain why a loan got rejected based on the rule we define. Okay, so that domain expert can define how why if the loan is going to get rejected, then why that loan is going to get rejected. Maybe some bank can set his civil score 550, 650, anything according to this. They can set annual income also. For example, if the user credit, okay, how this is working. Okay, so I am going to explain. If the user credit is below 650, okay, so we added low civil score. Okay, low civil score, so that reason will go. Okay, if that if the applicant income is less than 5 lakh, okay, then we mark it as insufficient annual income. Here we can see. Okay, so and in the last we define here what was similar we did here. Okay, and in this line, if none of condition are met, okay, if that condition will not met, then then we will just return unknown reason. But in most case the function will tell us user exactly what went wrong. This is homepage route. This is homepage route. Okay, this homepage route, when someone visit our website, we return html file, that home.html we created here. Okay, this one from here that user will input. I will explain you this code also after explaining this. Okay, this is our home.html. We contain the form where the user enter their loan data. Okay, and again this route handle up for submission. This route will handle for submission. It listen for post request, meaning it capture data the user entered in the form. Okay, it will capture the data the user will entered, okay, in the form. Okay, sorry. So now in here what we are doing. So here that all the data will come here, retrieve and process the data, whatever the user will input there in the form. Okay, if that user will input 650, it will come here. Okay, and here we are preparing for prediction. Okay, here we are preparing for prediction. Okay, and again what we are doing here, with new data we will transfer that new data, and we will use that model what we trained already, and that is in pickle file. Okay, if the result will get approved, okay, then if the prediction result will be equal to 1, then it will get approved, else it will get rejected. Okay, so like that we define the reason here, and we created a data frame. Oh sorry, then again that prediction result, okay, whatever it will be approved or either rejected. It will return to render template. Okay, and where is single prediction.html. Okay, it will come here and it will give the reason also. On this is our code here, and and this line the Flask server debug. Okay, and the debug equal to true lets us to see the error while testing. Okay, then and the host is 0.0, make the web app accessible for local network. So this was the application.py code. And if you will come here in the home.html, then we can see there is one form. Okay. And in upper part, there is the CSS I use just to look good our code. And the main thing is here that it is the form I created. Okay, that user will get input the value in this form, and that single dot prediction. Okay, from here that prediction will come. Okay, and it this will give the reason, and we created a link, go back to the home page. So this is our model. Okay, how I created. You will get all this code in the comment section or either in a description box. So we already tried. Now we will see some like again we will run this code. Sorry, just give me a 1 minute. I have to fix that issue. What the issue is coming. uh it is taking time. Just yeah, the code is here, and again we will follow this link. And here we go, we built a complete loan approval prediction app using Flask and machine learning. User can interact with it, get prediction, and even understand why their loan was rejected. Okay, so now again we will check again. So number of dependent is 2. This is self-employed, already graduated. Annual income is annual income is 10 lakh. Loan amount is 5 lakh. Anything you have to keep. Okay, that loan term, CIBIL score 700. Residential asset value you have to enter. Commercial asset value you have to give. Any random value you can give. Okay, bank asset value you can give anything, and let's see that our model is getting. Yeah, the prediction result is approved. Okay, now the next task is you have to do. You can add reason also why that loan is going to approve. Okay, what is the reason? High civil score, high income, how high annual income, or high that loan amount, or what was the reason of going to get approved? I added the reason why loan is not getting approved. Now you have to add one more thing, why loan is going to get approved. Okay, so you can use this reason if you want, and I will provide this all code in the comment section or in description box. If you like this walkthrough, smash that like button, comment, okay, and subscribe for more ML project like this. Okay, next, already I deployed this model, and be here to see a new project in the future. Okay, so that's it for today, guys. Thank you so much to be here.